Hello, both of you. Method of charging bodies. So this method, it includes all the things, whenever we are rubbing our hand, simple, it's due to friction. So from our one hand, it's going to another one. So it's getting charged. Same way when we are rubbing two materials, same thing is happening. Same way when we are any materials or whenever we are bringing nearby. There are so many methods of charging here. So first thing we are seeing, charging bodies by rubbing or friction. Now, when simple, it's very simple. Like when two bodies are rubbed together, so what will happen? There will be a friction between them. So due to that friction, there is a transfer of electrons. Suppose if we assume we are rubbing our hand. Okay, we are rubbing our hand. So from left hand, we are assuming that, okay, from left hand, the charge is going to the right hand. So right hand is gaining a charge and left hand is losing a charge. So what will happen if body lose charge? And what will happen if body gains charge? Which will become positive, which will become negative. Yesterday only we discussed, come on, tell me. When body lose electrons, will it be positive or negatively charged?
Positively charged.
And when body gains electron?
Negatively charged.
Okay. What about Earth? What about earthing? Is earthing a negatively or positively charged body? Is earthing a negatively or a positively charged body?
Earth, sir.
It is what? What do you say, Ajay?
So, the Earth you're asking, right?
Yeah, earthing. When
It's
we are doing
negatively
earthing,
charged.
it is? I'm sorry.
Negative.
Negative charge, okay. What if I say it is not negative then? Will it be positive? Okay, see, earthing is like a neutral charge. Whenever we are connecting something, suppose whenever we are drawing some, whenever we are drawing some circuit, we are connecting something here, and we are saying this is earthen. That means this is having zero potential. This is having somewhat 4, 5, whatever potential. So earthing, we are assuming it as a zero potential. It is neutral body. So whenever we are doing earthing, negative charge body will become neutral. Whenever we are doing earthing, that negatively charged body will become neutral. So overall, we'll get zero potential. So that is why we are doing earthing. So because it can accept all the electrons if it is excess, all the charges. That's why it is safe thing to do earthing. Like we won't get shock. Same thing, earthing. And what is the other thing to prevent? That is fuse. Fuse and earthing. These are two safety measures taken. Okay, let's come back to our topic. So charging bodies by rubbing or friction. So when two bodies are rubbed together, the friction between bodies cause transfer of electrons from one body to another body. And as a result, what will happen? Both bodies become charged. One body will become positively and another body become negatively charged. So when a body loses electron, it becomes positively charged. And when body gains electron, it becomes negatively charged. So as example is given here, that is rubbing glass with silk. Actually, it can be taken anything else like that. But see here, what we have convention here taken, charge on body, charge on glass rod, and fur is positive to be taken. And silk cloth and plastic is negative. This is for our convenience. It's not like they doesn't have any charge like that, positively charged, negative charge, not like that, but here for our convenience, we are taking it. Okay. Want to make a note of it?
Yes, sir. Sir, I'm done.
Okay. What about others? Are you done?
Yes, sir.
Okay. Remaining two?
Yes, sir.
Done.
Okay. So let's see next one. Charging by touching or touch. So when a charged body is made to touch an uncharged body. So actually what will happen, like there is an example for this one, like when uncharged body, yeah, it's here also, sphere is here. So if it is placed nearby, so this will get a, like suppose this is one charged body is here and this is uncharged body. If it is touching here, so this will, now this charge will be divided between those two. So it will have q by 2 and this will also have q by 2. This is B, this is A. If A is touching B, it will become q by 2, q by 2. It will divide equally. And after that, if it is touching the C part, which is also Q, so this will be A q by 2 plus Q, which is 3, 1, 2, 3, 3 by 2 Q. So each will have and divide by 2 also, right? So 3 by 2, 4, 2. It will be 3 by 4 Q. So now B will have 3 by 4 Q and C will also have now 3 by 4 Q. So new charge for A will be Q by 2 and for C will be 3 by 4 Q. So when this uncharged body brought nearby, it was touching A, then after that it was touching B, it will be like divided into half. Okay, so when a charged body is made to touch an uncharged body, some of the charge from the charged body is transferred to another body. So this is called charging by touching. Next is your induction. charging by induction. Two metal sphere A and B are we are bringing them nearby. So after that, same way, bring positive C rod near the left sphere A, and what will happen? If it is positive sphere, then this negative sphere or negative charge will be getting attracted towards the C, and positive charge will repel. So if we remove this one, this after that B will be fully negatively charged and A will be fully positively charged, uniformly divided. So see, when it is written here, not all the electrons in sphere accumulate on one side because electron keep getting accumulated here. Some are getting accumulated here. So the incoming electron feels a strong repulsive force from the already accumulated electrons. So once we remove this C, or when we remove this B separately, this whole sphere will have positively charged. So whole sphere will have here positive charge. Make a note of it if you want.
Done, sir.
Okay. Charging by induction also. Let's scroll up. Okay. Now next we will see electric field lines. You know, right? Like we are studying in 10th grade also. What are the electric field lines? What's electric field lines? Anyone?
They're like imaginary lines that give us like the representation of electric field.
Field. Your representation of electric field. Yes. So electric field lines, it starts from positive end and ends at negative end. So if I draw any electric field electric charge, you're saying here it goes outward, radially outward. And if it's negative charge, radially inward. Goes like this. Now, if it is only single charge, it doesn't go like this, it will go to infinity. Okay. So if there is single charge, this starts or end at infinity. Okay. So electric field lines cannot be taken to be continuous curve. It starts from here. So that is the reason it cannot be. It's not cannot be taken to be continuous curve. or closed curve, not continuous. It is continuous curve. It cannot be closed curve, we can say. So this one you already know, they never intersect, right? When they intersect, what will happen? There will be a two, like if I show you here, this electric field lines can never intersect because at this point there will be a two direction. If I draw tangent from it, there will be two directions showing. So which is not possible. So these are the properties of electric field lines. I hope are you understanding? If you're not, you can ask me any point, anything. Guys, are you able to understand or not?
Yes, sir.
Yes, sir, we're able to understand.
Three properties written.
Yes, sir.
Others?
Yes.
Three. Chalo. Here comes our next topic, that is dipole. Electric dipole. Now dipole means what? Equal and opposite charges. Two equal and opposite charges makes a dipole, which is separated by finite distance. Here it is electric dipole. Same thing we study in magnetic, there will be magnetic dipole. Whatever we are studying in this chapter, same thing we'll study in your magnetic chapter also. Dipole moment, dipole, there also dipole moment, dipole, there is, here it is electric, there will be magnetic. So dipole is what? Two equal opposite charges separated by some distance, a very small distance. Actually, it will be. So we are mentioning at 2L. It is 2L distance from the center. So that means from here it is L, from here it is L. So total distance between them is, from origin is LL to L. Origin in the sense center. Okay, so dipole moment. For dipole moment, having charges plus q and minus q are separated by distance 2L. It is defined as product of one charge and distance between two charges. Yeah, make a note of it. But yes, this is also okay. Net charge on an electric dipole is 0. 0 in the sense net charge is 0. Plus q minus q will become 0. Net charge, total charge. Are you understanding dipole moment?
Yes, sir.
Sir.
Okay, so make a note.
Done, sir.
Now, electric field due to a dipole. So we are taking a point P somewhere on axis. The same way what we wrote before, we'll get E equals to 1 by 4 pi epsilon naught 2p r cube. R cube here it is distance from origin or center. Let's not say origin, let's say center. From center O. Next, at a point P on equatorial line. This one, I've drawn this combinedly both. These are same, E dash 1 by 4 pi epsilon naught P by R cube. So P is your dipole moment, okay? What we wrote here, P is your dipole moment, 1 by 4 pi epsilon naught. Epsilon is permittivity. And it is epsilon naught means relative permittivity. So do you both remember what is permittivity? Yesterday we discussed something. Can you tell me? Drishi and Ajay, you both were there. One try.
Sir, epsilon naught was permittivity in free space.
Yes. What is it? What was it? Can you recall it?
Sir, I know what I cannot define it.
Okay. Not definition, but just okay, whatever. Fine. It is a simple. We can say like in simple words. If we say its capacity, we can say its capacity to store electric potential, or we can say to allow some electric field. So now we are taking epsilon naught. It is epsilon naught is for free space. See, these things you will have in magnetism also. So better learn it now itself. So where was it? Which slide? I don't know. Yeah, I think so. Here. Yes. So permittivity K, sorry, epsilon naught, it's for free space. And K is your dielectric constant. So K equals to epsilon by epsilon naught, which is equals to epsilon R. This is a relative permittivity. This is permittivity of material, any medium or any material, whichever we are using. So here we are using free space. So it is K epsilon naught. So K is equals to 1 for free space. Here medium is equals to epsilon K. So K is 1 for free space. That is what we are doing here. Okay, now let's try this question. Calculate net charge on substance consisting of 5 × 10⁻14 electrons B, a combination of 7 × 10⁻13 protons and 4 × 10⁻13 electrons. This is combination and that is just electrons. Come on, find the net charge. So what's the answer you're getting?
So first is 8 into 10 to the power minus 5.
Okay.
And second is 4.8 into 10 to the power minus 6.
ठीक है.
Sir, I don't know what I'm doing. Sir, I got -8.
Yes, that
That is
is
about
true.
minus
It's -8 if we say electron as minus
okay.
1.6.
And then I got
What about Laukya and Pranavi?
10.
Okay. You have taken enough time to solve. Come on. See, check your answer. Others. Q equals to any both things. For first one, it is electrons. So we will get -80 microcoulomb or 8 to 10 to the power -5. Same thing. Now for Q, we need to add both values, charge and for one proton, it is this much 1.7 in 10 to the power 13. And one electron is 4 in 10 to the power 13. So both are almost same. 11.2 minus 6.4, it is 4.8. Try this one. A piece of polythene is rubbed with the wool, a charge to 10 to the power minus. I think so. This is an NCERT question, if I'm not wrong. I don't know. Let it be. After finishing this chapter, we'll do all JEE questions, UIQs. Any idea you're getting?
So can you tell the value of the mass of electron?
Mass of electron is 9.1 in 10 to the power minus 31.
Um, 1.0 0.9 into 10 to the power minus 18.
Okay, okay. It's 11.3 in 10 to the power minus 19, or same thing. What about others? Are you trying? Turn on the camera, everyone. Let me see. Are you trying or not? Quick. Joshi, Lokya, Ajaya. Joshi, Lokya. Okay, what you will do here? What we need here, by the way? We need total mass. So for finding total mass, we need total number. So for finding total number, what shall we do? How to find number? Total number of electrons. How to find Q equals to? Yeah, somebody wrote something. Let me see. 12 minus 19. Okay. Yes, it is correct. So total mass equals to mass into total number. So number equals to Q equals to NE. Right? If you remember, just now we did here. Q equals to NE. So N equals to Q by E. So Q we have 2 to the power minus 7. And E equals to 1.6. That's it. Over. Okay, Pranavi, finish it fast. We'll move to next. Try this question till then, those who finished. Ajay, I guess you finished. Pranavi, you also finished, right?
Yeah.
Okay, you also? No?
Answer.
Solve it. Next one. Rishi, turn on a camera.
Yes, sir. 1 minute.
Yeah. And solve this one also.
Sir, I didn't really get the question. Like the negative charge is placed like around, like on the same point as
Next
Q.
to the Q. Yeah.
So is it like there's a distance between Q and minus Q?
Yeah, there are minus Q, plus Q and capital Q. So the two forces between 2 point charge, there is small q, capital Q. As you can see here, small q and capital Q at rest, and its force is F. And if a charge minus Q is placed next to Q, somewhere here or here, whatever, what will be the force due on Q due to Q? Means new force, we can say.
It should not change
Why so?
because principle of superposition.
Sum of forces. Okay, let's see. And what about B? Total force on Q.
That will be 0.
So net force on Q will be 0. Okay, see. Oh, okay. What about other three? Are you thinking?
So I said my answer in the chat.
Okay, I got 3 answers. Okay, uncharged because of force between the particles getting and some other particles. Okay. Okay. Fine. It's similar answer to her. Same. Okay. Any other answer? Like I'm waiting for some other also. Ranamir, okay. What do you think? So yes, your answer is correct. So charge will be unchanged, will be same, and total force on Q will be 0. Okay. Yeah, try this one. Distance. This is distance L. Okay, it's not 1, it's distance L. Charge Q1 minus Q placed in them respectively. They are lying. See of oscillation. Oh. Yeah, nice. This also, I think, NCERT equation maybe. I guess Drishi is ready with the answer.
Sir, actually, I cannot do it.
No, I thought your face was confident. Yes, I'm ready. No? Okay. And Ajay is busy in thinking. Went away.
Yes, sir. I don't know what to do with this question. Trying to think of solutions.
Okay, no problem. And let's solve. What about you two?
Prime.
Okay, come on. Try. Let it be right or wrong, you should get something. Excuse me. When you see the question, don't get stuck. Okay, what is this question? Like how to solve? No. Something. Get the way to out of it. Anyhow, if you get wrong, who's going to judge? Got wrong. Chill. Solve it. चलो ठीक है अब साइलेंस खोल ही देते हैं बहुत हो गया what it says consider two object and all this nonsense I'll erase it okay consider two object of mass m and 3m are separated by distance l so this distance is l m and 3m somewhere I have drawn this right doesn't matter any it can be anywhere so it should be one should be plus and one should be minus q no m this is plus this is minus I placed them respectively okay so obviously if it is like this there will be movement at the center of this one at the see this is line I want 1/3 here and 3/4 will be here 75% here remaining 1/4 will be on this side 1/4 of length will be at this point so suppose like if you can see me if I want to balance this here I cannot balance it here at not exactly at the center also because this side it is thick this my writing pen is thick this side so I cannot move it at exactly center I need to move somewhere nearby so that it will be balanced somehow if I'm moving at the center it is bending this side because of this weight Same way, I need to move here because this weight here, more mass is there, 3m mass is here, and m is here. So if I want to balance this one, I need to move near to 3m. So this total is 4, so it will be 1/4 of this one will be here, remaining 3/4 will be on this side. So center of mass will be at 1/4 of the distance. So we found here center of mass first. So center of mass we found exactly at this point, 1/4 of the distance. So total is L. That's it. We will do center of mass thing here. Do you remember system of particles? 11th standard, I think so, some months back only, right? Or a year back. Ajay, when we studied? 1 month back, right? 3 months back, I guess.
Yes, sir.
Then you should remember.
Yes, I should have after my
Okay,
exam.
okay. Let me see. Then remaining thing you can do like simple, like a 3ma plus 0 by 4m. Total mass is 3 plus 4m, 3m plus 4m. The distance is 4m. So x, it will be 3 by 4a. That's we already did orally. Simple. Like we need here tau equals to EA sin theta. Displacement here. Then I we need, okay, so many things, right? Fine. Torque we have not discussed yet. So let us discuss torque then first. So for torque, so if you remember, it's similar to our 11th standard only. Torque means what? How much is applied here, how much force applied here, and it got movement. This my pen got movement here. So that is my torque. Rotation, it will give you rotation. Force applied on this one. So when these are equal and opposite charges, PE sin theta. Now this is also depending upon angle. If it is same and electric fields are placed, it will not have a movement. Now if it is placed in electric field at some angle, so it will have some rotation. This dipole, P is your dipole moment, and E is your electric field. So T equals to PE sin theta. Now, as we found a center of mass, we need center of mass for finding here acceleration, this one, like a moment of inertia. That is I. From here we are doing here. I equals to tau equals to I into alpha. Okay, we haven't discussed all this yet. Let's do one thing. Let's come back to this question again. We'll discuss that first, and then again we'll come back to this question. Because if I say then also it will be going bouncer. You will not understand anything. So it will be like I'm blabbering something. It will go away. Okay, fine. Then let's stop here itself, because then we need to discuss this. We'll discuss this next class first. We'll see this torque, how torque and how it will be affecting electric field. We'll see that first tomorrow. Tomorrow we have class, right? Do we have class tomorrow? Not tomorrow. Wednesday. Okay, we'll have on Wednesday. Fine, whatever it is. So first we'll discuss that and we'll do this question again. Okay. I'll stop this sharing. Even you're not studying in school only, right?